Good morning everyone. Today we are going to perform experiment number 21 of applied electronics, that is how low voltage regulator using IC LM723. So it is this low voltage regulator, it is used to regulate the voltage at lower level from 2 volt to 7 volt. So this is the circuit diagram we are using. So here different pins are there. Here VCC is given, then we are connecting R1 and R2 here. This is V minus, that is negative voltage, and this is V plus. V minus is the negative voltage, and above that there is a V plus, there is a positive voltage. So here we are giving V input voltage. This is inverting terminal, which where we are connecting a capacitor, and this is non-inverting terminal, and this is the reference voltage, and from here we will get the output voltage. So the basic purpose of LM723 IC is to get a regulated output. Regulated output means what? Constant output at any time, constant. So this is basically used for DC. So this is given as an unregulated DC supply. Okay, now we'll go back to the observation table. Let's see the observation table. So this is the observation table. So here the load register, which is a load register, is given constant, kept constant, which is 12.12 kilo ohm, which is constant. And as we vary the, and here two columns are there. As we vary the input voltage here, there will be a slight changes in the output voltage. So this regulator voltage gives the constant voltage between the range 2 to 7 volt. That is why it is called as a low voltage regulator. Okay, now first observation table will keep the load resistor constant, and we will have to vary the input voltage from the function generator, and we'll get the output here. So this is the input voltage, and if you can see here, the output voltage ranges between 2 to 7 volt, and it is almost constant, which is just output voltage is almost remains the same. There is a slight changes between 0.2 or 0.3 difference. Okay, now in the second table we have to change the load, and earlier we have kept the load constant. Here we have to keep the input voltage constant, which is 11 volt, and here we have to vary the load current, and depending on that we will get the output voltage in volts. So initially the 52, whatever the value we have received, the load current, there is a load current which we have received here, that is, and does not give any load, and its output voltage is 4.97. Next 55.5, which has the low load, which has given output voltage 4.92. Next 59.4, which has the medium load, which is 4.90, and high load is at 62.5, which is 4.88. So there is a calculation I am to show you. To just a minute, I'll show you. So this is the output voltage, which is almost remains the same. There will be a difference of 0.2 or 0.3. Okay, otherwise almost the load is close between 2 to 7 volt. Now we'll see the main calculation. So here line regulation can be denoted as delta V out upon delta V in, that is change in output voltage upon change in input voltage. How will you find out the change? Here we have to take the difference of two voltages, input voltages, that is 8.60 minus 9, or any output voltage out of this, and you will get the change in input voltage. So I have taken these two, 10.03 and 10.60. Okay, if we and change in output voltage, there will be a difference of any two output voltage we'll take. As we have taken 10.03 and 10.60, we'll take the output voltage of the same, and after that we have to calculate the formula. Now load regulation can be calculated as no load voltage minus full load voltage upon full load voltage into 100. So here no load voltage is at, we look at the table, 4.97 minus 4.88, there will be full load into 100, and if we have got the load regulation as 1.8%. Okay, so this will be calculated as using the table. So here no load is at 4.97. Let's see whether you have got the table or not. So this is all about your 21 experiment. I hope you have understood the concept. Thank you.